So last day we have discussed about the conflict in SLR1 parsing table, and we have seen that how the SR conflict and RR conflict can be found in a SLR1 table. What is the criteria for that? And based on that, maybe question will come like grammar will be given to you, and you will be asked that whether SLR1 part it is SLR1 or not, or LR0 or not, or something like that, right? So basically, if I go back to that chart, this one, you see, this two part we have already completed, right? This part is done and this part is done. Now this two part is left, and these two in a different category. I hope you can see that is it uses canonical collection of LR1 item. So before we before we understand that how this LALR1 and CLR1 parser work, I mean how the parsing table of these two parser is designed, we have to understand what this LR1 item mean. Okay, so let's write here again that how we can understand this LR1 item. Remember, LR1 item can be considered as LR0 item plus Lookahead. Okay, just like 2's complement equal to 1's complement plus 1 is something like that, right? Now question is that what does Lookahead mean? So if we take an example, I hope it will be much more clear. So assume that we have a grammar something like, so we have an example. So assume that we have a grammar something like s2 dot a, capital A, and then after comma I will write either A or B. Okay, either A or B, or maybe there is another production rule something like s2 like a dot. Suppose that this is a final item a dot, and in that case the after comma I have C or D. So all these things actually are called, these two, in both cases these two are called look ahead. Now what does it mean? This look ahead will be useful at the time of, again, time of reduce move. You see, again the same concept is coming. We have seen in case of SLR1 table that there is no change in case of shift move. If you compare the state diagram for LR0 parsing table and the state diagram for SLR1 parsing table, you will see that uh, I mean, with respect to state diagram, first of all, there is no difference, but with respect to parsing table, if you see that in case of the rows which have shift move, there is no difference. The difference is only on the reduce move, right? So this reduce move also is little bit, I mean, little more, you can say stricter in this particular LR1 item also. So what does look ahead mean? So let me write it. I hope it will be much more clear. I mean, what does this production mean? I mean, let me write it here that this production mean if you reach to final item, that means you have to reduce, right? Then don't place. I mean, then don't place the reduce move in entire row which reflects LR0 parsing table, or in the follow of LHS, this reflect the SLR1 table, but I can write just place the reduced item, I'm sorry, the reduced move in the look ahead symbol. So this is going to be very vital for, it's going to be very vital for uh, you know LR1 and CLR1 parser, because the both uses canonical collection of LR1 item, and in case of LR1 item we do that. So that means what I have done actually, we are not talking about the shift move again, so that means the shift move remains same. But in case of reduce move, what we are saying, don't even, you don't need to place in the entire row, you don't need to place even in the follow of LHS. I'm filtering it more and I'm saying that just place in the look ahead symbol. That means somewhere over here. Maybe the number of symbol present in the follow of left hand side is much more than this look ahead symbol. It may happen. And I'm saying I've written here A or B. I mean, there is a possibility that look ahead can be A or look ahead can be B. That's why I have written A or B. But you know, in some cases I can have only one symbol, that is the look ahead, right? So it totally depends upon some situation. So how to find this look ahead, that is the first, I mean, that should be the first important point, because you know, when you will start designing the state diagram, not only here production rule is important, this lookahead is going to play a very vital role. So that means we have to understand that if a grammar is given to you and if I want to design an augmented production, I mean from that grammar, then how we determine the lookahead from the very beginning. So let's take a very simple formulation over here. So assume that we have a production rule, something like a uh, a to say alpha dot b beta, okay, which have some look at a or b. Okay, so I'm just writing in an arbitrary way so that I can you can understand how to find this look at. Okay, now see, you see, since I have a dot before B, that means according to the logic we know that I have to find the closure of B, right? That means I have to add all the production rules where B is in the left hand side, and assume that we have a production rule something like this, B to say for example dot R, which is the production rule present in my grammar, and that's why I have added. Now question is that what will be the look ahead over here. So suppose that the look ahead is L. Okay, suppose the look ahead is L. Now what this L mean? L is this look ahead. This is the look ahead. Fine. Now how to find this? You see, always remember that whatever present after B that we have in this previous production rule, you see I have actually find the closure of this B. So other than after this B, whatever left in this production rule, that means this one, that means this part, specifically this part, right? The first of this whole part is going to be the look ahead of this one. So L you can consider as first of this, uh, this beta followed beta or AB, the whole part, first of this. So first of this means what? Obviously first of this beta comma a or b means first of beta. If we consider that first of beta is equal to c or d, assume that first of beta is equal to c or d. I can have two things, first of beta. That mean I can say that I will write b to dot r, after comma I will write c or d. Okay, this is one situation. This is one situation we can have. So let's just make a line here. Why I'm saying this is one situation, because I can have another situation in the same, for the same grammar. For example, now the grammar is something like this: a2 uh, alpha dot b, and after b I have nothing. I have just some lookahead. Okay, after b I have something, nothing, I'm just lookahead. So if I have something like this, definitely because of this dot before capital B, I have to find the closure of capital B. That means B to the production rules, all the production rules I have to add, where B is in the left hand side, and assume that I have only one production rule, that is B to R. So I will write B2 dot R, and what I will have over here in the look ahead, you see, in this particular case, after B there is directly comma. I mean, just like if you compare this to scenario, if you compare this part, whatever present after B, what is this? Beta, then comma A or B. Here nothing, comma A or B. So that means if we consider the first of this, obviously comma will not come first, because comma is actually, is expressing, just differentiating the lookahead and the actual, right hand side production, right? So that means in this situation there is nothing before comma and after b. So that's why naturally when you will add this production rule, the lookahead will be definitely a or b, like this. So in this way we can find out the lookahead of a particular symbol. So now let's take a very simple example, so that we can have a simple practice that how we can actually find a lookahead of some production rule. So assume that we have a grammar like this. A The same grammar, let's take the same grammar that we are using for designing parsing table in LR0 and SLR1, that is S2, I'm sorry, it's not A, I should have S. Okay, I should have S. uh, the original grammar I'm just writing, I'm not considering any lookahead or something like that, or any item. S to AA and A to small a capital A, or it can be small b. So this is my grammar, right? Now if I want to design the state diagram for this LR1 items, I mean for designing this LALR1 parsing table or CLR1 parsing table, definitely I have to design as a augmented production rule first, right? And that's why I need an augmented grammar, that are all you know. And that augmented grammar will be nothing but some, addition of new production, where I will find a new non-terminal which can derive to the present for start symbol. Like over here I will use s dash arrow dot s, right? And obviously from this production rule itself my lookahead calculation will start. Okay, so that means after comma I have to write something, right? What I will write? Definitely I will write dollar. Why? Because always remember, as we all know, that if you take a very simple scenario like this, For example, you have a if some you have some character over here like this. Okay, so assume that this whole character is representing your s, right? Somehow you will represent your s, right? And definitely this character has to end with a dollar, right? That's why look ahead of always look ahead of this s is always dollar. That we all know. Fine. Now from this production rule onwards, let's apply the rule that we have seen in the left hand side or right hand side. You see, since I have dot before this capital S, so naturally I have to do the closure of capital S. So what I will do, I will do S to what? I will write S to A, but I will write dot A, right? Dot A, fine. But after comma, I have to write something. What I will write? You see, I'm exploring this capital S over here. Actually, I'm doing the closure of this capital S. So if I'm doing the closure, whatever left after this, first of that will be the lookahead of this production rule. It is exactly same situation we have seen in the right hand side over here. You see that I'm basically find the closure of this capital B, and there is nothing after B. I mean nothing means actually nothing before comma after B. I have directly some look at present. Same thing over here. Since I'm nothing here, I will blindly write dollar. There is no other way. Now let's move on. You see, I have capital A after this dot here again. That means I have to explore this capital A also. And I will write, there is two possibility obviously. Either it can be dot A capital A or it can be dot B. Right. Even you can write A to dot B also. That's not a problem. Okay. You can individually think them because that's actually that's true. Now see, what is the going to look ahead of this symbol, this particular production rule or this production rule? It's going to be vital. You see, what is the reason behind this generation of this production rule? Because I had this first A, and I was actually found I was trying to find closure of the first capital A, not the second capital A, right? So that means after this first capital A, whatever left, first of that will be the closure of this production rule. So whatever left is this, right? Whatever left, in previous case, this part left. Now in this case, this part left because we are finding closure of first capital A, not the second one. In this case, first is obviously dollar. But in this case, if you find the first, it's not dollar, right? It's actually first of capital A. What is first of capital A? From this grammar, you can see first of capital A can be either A or B. So first is basically A or B, right? So that means when I will add their closure in this production rule, for this production rule, the closure will be what? Will be A or B. I mean, I will write there is a two possibility, either A or B. Here also either A or B. Now why in both cases either A or B? Because in both cases I have same LHS. Actually same LHS. So let's do one thing. Don't write slash here so that you can uniquely or individually identify how the lookup can be done. So this is the way by which we will start the state diagram design for the LR1 items. Now we have to see how we can design the state diagram and what difference we can find in the state diagram with previous cases.